Hi everyone, my name is Nikhil, Assistant Professor, Department of Mechanical Engineering, Jyoti Engineering College. In this presentation, we are going to discuss about columns. So these are the expected outcomes of this presentation. Now what is a column? A column is actually a structural member subjected to axial compressive force. Normally columns carry heavy compressive loads and columns are used in concrete and steel buildings. So here you can see a real world example in this figure, or this figure shows the elevation of our college, and in this picture you can see a number of columns are uniformly arranged. As I said earlier, the columns are meant for carrying loads, but here surprisingly the arrangement of the column enhance the aesthetic of this building. Now we can discuss the concept of stability of column. When a perfect column is subjected to a compressive axial force, the only deformation that takes place is a shortening of the column. For low values of load F, if the column were to be deflected laterally by a force perpendicular to the column and the lateral force were thereafter removed, the column would return to its straight position even with the force F remaining in place. This indicates a condition of stability. But if the load F were increased, there is a value of F for which, when the lateral load is removed, the column would remain in the deformed shape. This condition is referred to as buckling, and the column is said to have failed from a structural standpoint. Buckling can also be described in simple terms as bending or bowing of a column due to a compressive load. Now, what are the differences between column and strut? Strut is actually a structural member subjected to axial compressive force. Strut may be vertical, horizontal or inclined. The cross-sectional dimensions of strut are small. Normally, struts carry smaller compressive loads. Struts are used in roof truss and bridge trusses. Now what is a column? A column is actually a vertical strut. The cross-sectional dimensions of column are large. Normally columns carry heavy compressive loads and columns are used in concrete and steel buildings. Now what are the types of columns? So here you can see a very simple classification of columns, that is long, short and intermediate. Now what is a short column? When the length of the column is less as compared to its cross-sectional dimension, it is called the short column. Or we can say when the ratio of effective length to the least radius of gyration is less than 45, then it is called a short column. Here you can see the relation LE divided by R minimum less than 45, where LE equal to the effective length of the column, R minimum is the minimum radius of gyration. If the ratio of LE by R minimum less than 45, such if a column satisfies, or if a column is coming in this category, that is called a short column. Now one more term you have to study is the crushing load. Crushing load is actually the load at which the short columns fails. Now what is a long column? When the length of the column is more as compared to its cross-sectional dimension, it is called a long column. A long column is subjected to a bending moment in addition to direct compressive stress. The load carrying capacity of a column is less than a short column, and the load carrying capacity of a long column depends upon slenderness ratio. Slenderness ratio increases, then the capacity of the column decreases. And here we have the relation LE by R minimum is greater than 45. That is the condition for long column. Now what is an intermediate column? If the value of LE by R minimum lies between 30 and 100, then it is called an intermediate column. Now, what are the different causes of failure of a column? The failure of a column takes place due to any one of the following stress set up in the column. It may be due to direct compressive stress, or maybe due to buckling stresses, or maybe due to a combination of direct compressive and buckling stresses. Before we move onward, you need to understand the terms crippling load, radius of gyration, moment of inertia, area, effective length, slenderness ratio, stronger axis and weaker axis. And some of the terms you are already studied in engineering mechanics, for example radius of gyration and moment of inertia. Now, what is crippling load? The load at which long columns start buckling or bending is called buckling load or crippling load. Buckling of column depends upon the following factors: amount of load, length of column, end conditions of column, cross-sectional dimensions of column, and material of column. Now, what is radius of gyration? It is normally represented by K. Very simply we can say it is the minimum distance from centroid to the axis of rotation, and we have the equation K equal to under root I by A, or I equal to A K square, where K is the radius of gyration, I is the moment of inertia, A is the area of cross section. One more point you have to notice that resistance of a member to bending is proportional to moment of inertia of cross section. Now the next term, effective length. It is normally represented as LE. It is the distance between points of two zero moments, and it depends upon the type of support conditions. Now let's discuss the column end condition and effective length. So here we have four conditions and we can discuss one by one. We can start from left to right. Now coming to the first condition, in this figure you can see both ends of the column are hinged and a load P is acting at the top of the column. Here the relationship between effective length and actual length is LE equal to L. Coming to the second condition, the bottom end of the column is fixed and the top end of the column is free, and at the top end load P is acting. Here we have the relation LE equal to 2L. And coming to the third condition, both ends of the column are fixed. Here the relationship between the effective length and actual length is LE equal to 0.5 L. Coming to the fourth condition, it's one end is fixed and the other end is hinged, and the relation between the effective length and actual length is LE equal to 0.7 L. So these are the four different end conditions and relationship between effective length and actual length of the column. Now this table is very important. In the exam point of view, you can expect one sure question from this area for finding out the crippling load. So we have the formula in order to find out the crippling load PE. But one thing that you must thorough with is you must understand the relationship between effective length and actual length corresponding to the end condition. If the end condition is given as the both ends of the column are fixed, you must understand that the relationship between the effective and the actual length is LE equal to L by 2. Okay, so you must thorough with this table. Now what is slenderness ratio? It is normally represented by lambda. Slenderness ratio is the ratio of the length of a column and the least radius of gyration of its cross-section. It is used extensively for finding out the design load as well as in classifying various columns in short, intermediate, long. We have the relation lambda equal to LE divided by R minimum. We already studied this slenderness ratio in the previous slides. Now, what is the significance of slenderness ratio? It is very important. As slenderness ratio increases, permissible stress or critical stress reduces. Consequently, load carrying capacity also reduces. So, it is better to keep a lower slenderness ratio as far as a column is concerned for carrying more load, or in order to increase the load carrying capacity. Now the next very important topic is Euler's formula. So you must study what is Euler's formula, then the assumptions of Euler's formula, and the last one is the limitations of Euler's formula. Now we can discuss the assumptions. The first assumption is column is initially straight and the load is applied axially. Cross-section of the column is uniform throughout its length. The third one is the column material is isotropic and homogeneous. Length of the column is very large compared to its lateral dimensions. Direct stress or compressive stress is very small compared to buckling stress. The column will fail by buckling alone. And the last assumption is self-weight of the column is negligible. Now here we have Euler's formula in order to find out the crippling load PE. The relation is PE equal to pi square EI divided by LE square, where E is the modulus of elasticity, I is the moment of inertia, and LE is the effective length. This is also known as critical buckling load. Now, what is the limitation of Euler's formula? Very simply, we can say Euler's formula is only applicable for long columns. That means it is not very effective, or it is not applicable in the case of short and intermediate column. So in order to overcome this limitation, we have Rankine's formula. So Rankine's formula in order to find out the crippling load is PR equal to sigma Cs into A divided by 1 plus A into LE divided by K the whole square, where PR is the crippling load by Rankine's formula. Sigma Cs into A, which is equal to PCS, is the ultimate crushing load for column, and PE is the crippling load obtained by Euler's formula. The other parameters are A equal to cross section of the column, K equal to least radius of gyration, and A equal to Rankine's constant. So using this Rankine's formula, we could find out the crippling load for short and intermediate columns. So the limitation of Euler's formula can be overcome by using Rankine's formula. So these are the main topics coming in this presentation. Hope you all understand. Thank you.